I'll say that much. All right, good afternoon.
So warm for you, James. You're so bad at every video game you play, it makes me want to cry.
All right, here we go. We are solving trig equations today, which is going to combine algebra techniques and the unit circle. The nice thing is all of your answers can be checked. Thank you. I do need that. Perfect. All of your answers can be checked on your calculator. So first of all, can we, because I was doing something, I'm not sure whose calculator I used. Oh, Thomas isn't here. Is he here? He's here. He should be doing his test, but like I haven't seen him, so he was here. Okay. 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 So in your calculator, will you make sure that you're in rectangular mode? What? I know, yeah. Radians. Radians, and make sure you're in rectangular mode.
Hey, how do you do that? Like graphic?
Oh, sorry, function. Make sure that says function. I used someone's calculator, and I'm not sure who, and I didn't change it back.
Sorry, I'm like, how do we get that?
Mode. Oh, that's why I can't find it. I'm on the wrong. Okay.
Mine looks exactly like yours, except the date's a little different.
Okay. All right. Here we go. 9. Okay, there's the code on there. All right. So just making sure you're still in function graphing and radian mode. Always a good thing to be in. Okay. So we can graph equations, and you can check your solutions. And in fact, just as a reminder, you can solve any equation graphically. So you have an equation like this. In your calculator, you put the left side in y1, you put the right side in y2, and you find the intersection. And it is a fantastic method for checking your answers. Now, of course, in Delta Math, they won't want decimal answers, but you can certainly check your answers and see if they're right. So we're going to get exact answers. But you can see here in the left side, I'm going to go ahead and type in 2 cosine in y1, and then just 1 in y2. And you can just do a zoom trig. So click on zoom and do a zoom trig, and that's usually a pretty good window for trig functions. So this is a cosine curve with a maximum of 2 and a minimum of -2. And the solution is everywhere they intersect, all right? How many solutions are there? An infinite number of solutions, okay? And that's important to understand because trig functions are cyclical, they repeat. We get lots of intersections, and so lots and lots of solutions. And so typically, you're going to see a restriction that says, hey, we're only interested from 0 to 2 pi. And so we only care about the intersections between 0 and 2 pi, and that makes life a lot easier for us. And so here in this part, we can see we're interested in this intersection right here and this intersection right here. Now, we could find it graphically on our calculator. You're going to go to the calculate menu, which is in blue. So what do you have to do? Second, calculate. And we want the intersection. So you're going to choose number 5. And you're going to move Tinkerbell to that intersection and do enter, enter, enter. It's the fastest and easiest way. And so you can see that intersection is at 1.407, which is no good on Desmos, okay? Or not, sorry, it's no good in Delta Math. But you can see that here, I changed the steps so I can see that the intersection is at pi over 3, comma 1. So the solution for this is x equals pi over 3. What's this solution? Yeah, and 5 pi over 3. So those are the two solutions for this particular equation on a 0 to 2 pi interval. But it's a great way to check. So I'm getting 1.047. If I quit and go pi divided by 3, you can see it approximates to 1.047. So it's a great way to check your solutions and make sure you're correct. So this is great. You can get 100% really easily. Now, it is going to use up your knowledge of the unit circle. So we want to make sure that we remember our unit circle. So let's start here. How many radians am I if I'm right here? 0. And up here, that's pi over 2, 1/2 pi right here. Pi down here, 3 pi over 2, and then all the way around 2 pi. Okay. Now, if we take pi and cut it, split it. There we go. See that? I've got 1, 2, 3, 4 wedges on top. I'm going to do the same thing on the bottom. Okay. So now I took pi and I divided it into 1, 2, 3, 4 wedges. So what does this dot represent then? Pi divided by 4. This is 1/4 pi. This becomes 2/4 pi. This becomes 3 pi over 4, or 3/4 pi. What's this one? 4/4. 5/4 pi. This one is 6/4 pi, and our last one is 7/4 of pi, or 7 pi over 4, okay? So again, we're sort of just counting. You can see, again, these are odds, 1, 3, 5, 7. Maybe that's something useful. Okay, but I can also divide this. Let's do the ordered pairs for these. What's this ordered pair here? 1, 0. Funny, okay, all right. 1, 0. What's this ordered pair? Radical 2 over 2, comma, radical 2 over 2. Good. Do I have to do all the others, or can I leave it like that? Is that okay? 0, 1. Okay. I'll just do the first quadrant and the quadrantal angles. -1, 0, and 0, -1. Very important that we know those. Okay. Okay. But we can also take pi and divide it into 6, technically, is what I'm going to do. There we go. So here I can see I have 1, 2, 3, 4, 5, and then get to 6. So I have 6 purple dots there, which means I took pi and I divided it into 6. So this is pi over 6. 1 pi over 6. What's this purple dot? 2 pi over 6. 2 pi over 6, which is pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6. This is 4 pi over 6, which reduces to 2 pi over 3. And over here is 5 pi over 6. I could do the same on the bottom, but I'm not going to. Okay, what is the ordered pair here at pi over 6?
1 over 2.
Yeah, in the x direction, this is the long side, so it's radical 3 over 2, and then up is the 1/2. Very good. So we had the long leg and then the shorty, so the shorty is 1/2. What's the pi over 3 ordered pair? Yeah, so again, if you think about drawing that triangle, we have a short leg and then the long leg, so it's 1/2 and then up radical 3 over 2. Fantastic. Okay, so this is just that first quadrant of our unit circle. Really important that we have all the answers there. Again, you can print it off if you want to, but it is good to have and even better to be able to create. So I do enjoy spending the time to do that. So this is important. I also want to remind you that the x-coordinate represents the cosine of our angle, and the y-coordinate is the sine of our angle. And how do we get tangent? Divide what over what? Sine over cosine. Yes, tangent is sine over cosine, or y over x, all right? So sine over cosine, we're good to go. So we're using all of this in some algebra to figure out some equations here. All right, let's just turn the page. So, Bruno, so the trigonometric equation for all values between 0 and 2 pi. So they just want one rotation of our unit circle. And we, our goal to do these equations is essentially to isolate the trig function. So we want to get the sine, cosine, tangent, or whatever all by itself. So I want this sine of x alone. What do I need to get rid of? Subtract. So I have 2 sine of x equals negative radical 3. So we're going to subtract. And then what should we do? Nope. Is sine alone? Divide by 2. This is 2 times sine of x. So we need to divide by 2. So we get sine of x equal to negative radical 3 over 2. So this is asking a question on our unit circle. So I always just make a little circle here. Where is the sine coordinate equal to negative radical 3 over 2? So this is the y value equal to negative radical 3 over 2. That's a very long y coordinate. That is like negative sine. It has to be down here. Okay, so this is not arc sine. This is on the unit circle. So this right here, what angle has a coordinate of negative radical 3 over 2? And this one also has negative radical 3 over 2. So we have 2 angles that have the y coordinate being negative root 3 over 2. So that is what we're looking for. What angle? Let's see. So that is 1 pi over 3, 2, 3, 4 pi over 3, and 5 pi over 3. Okay. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. You can check your answers. If I were to check this answer, the best way to check this answer would be to put the left side in y1 and the right side in y2. How come I'm not checking like down here or this one? Like, it doesn't matter. In case I made any mistakes. Yeah, this one is perfect and free from mistakes. So 2 sine of x plus radical 3 in one side, and I am going to put the 0 in the other because calculating the intersection is like the easiest, fastest way. And then I'm going to graph it. And so here's our sine curve, shifted up a little bit with an amplitude of 2, and where it intersects at 0, and so I'm interested in these 2 points between 0 and 2 pi. And so I'm going to go ahead and calculate that intersection, and I'm just going to move Tinkerbell. And just hit enter, enter, enter. And it says 4.1887. So I'm going to check that. Is it 4 pi over 3? Yeah, 4.1887. Okay. So I know that I did it right, and so that's really, really good. So number B. What should we do first? Minus the radical 3, so we get 3 tangent of x equals negative radical 3. Divide by 3, divide by 3, so we get tangent of x. So tangent of some angle equals negative radical 3 over 3. So again, I'm going to go back to my little unit circle. Negative I'm going to look at my first quadrant here. I know, yeah, it's, what did you say?
Can't be in the first or the third.
True. Yeah, it does have to be in quadrants 2 or 4, but I'm just checking my ordered pairs here. This one is radical 3 over 2 comma 1/2. How do I get a tangent ratio? Y over x. So 1/2 over radical 3 over 2. The 2's cancel out. I get 1 over radical 3. Oh, that's how we get radical 3 over 3, right?
Yeah.
Okay. So this pi over 6 angle, but I need it to be negative. So right here, yeah, and this one. And right here, because we get negatives, oh, I did that backwards. Of course I did. So right here, radical 3 over 2 down 1/2. Okay, and this one was left radical 3 over 2 up 1/2. Okay, so these 2 points get me my radical 3 over 3. That is negative. What angles are those? Yes. And 11 pi over 6. Beautiful. Good. 5 pi over 6 and 11 pi over 6. All right. Good. Questions so far? All right. It just takes time. Reciprocal functions. Again, what should we do? Divide by radical 2. So we get secant of x equals 2 over radical 2. Now, I'm not going to clean that up right now because I don't want to look at the secant function. What do I care more about? Cosine. So we're going to take the reciprocal of both sides. What is the reciprocal of secant? Cosine. And what is the reciprocal of the right-hand side? Root 2 over 2. Hey, that's a number I know. Okay, so back to my unit circle. We want to know what angles have a cosine of radical 2 over 2. Yeah, right here at pi over 4 is radical 2 over 2. And where else? 1, 3, 5, 7. Right here is the other positive cosine value. So 7 pi over 4. All right. So knowing that unit circle becomes very helpful here. Okay. And I always, even to this day, I still just draw the circle and like count. So I still do it. It's funny too because a lot of people do. I see it all the time when I'm going through calculus papers and grading. When I take actual calculus tests, they have student responses. They too do circles and dots all over the place. It's funny. All right, over here, D. What are we going to do for number D? Add 2, so we get radical 3 times the cosecant of x equals 2. And then what? Divide by radical 3, divide by radical 3. So we get cosecant of x equals 2 over radical 3. But I don't like cosecant. It's not as friendly. So what am I going to do? Flip it. I want the reciprocal of both sides. The reciprocal of cosecant is sine. And flipping my fraction becomes radical 3 over 2. All right, so where does my sine value have a tall radical 3 over 2? True. That is pi over 3, yeah. So x equals pi over 3. That's the first one. And what's the second? 2 pi over 3, yeah. All right. Are you okay with this? Are you okay? Okay. What?
Only one of these, right? You have to do both of them.
Really need to practice. All right. All right, we got 2 more to do and then we're done. What should we do first? Add 3. So we get 4 sine squared of x equals 3. And then we can divide by 4. So we get sine squared of x equals 3/4. And then how do we get rid of the square? Square root. Now here's the tricky part. When you take a square root, what do you need to remember? Plus or minus. Very important there. So we get the sine of x is going to be equal to plus or minus. This becomes the square root of 3 over the square root of 4. So that becomes, yep, radical 3 stays. The square root of 4 is 2. So now we want all of the radical 3's over 2. That is the y-coordinate is radical 3 over 2, positive and negative. These are all my tall triangles. All right, those are all my tall triangles, which would be pi over 3, 2 pi over 3, 1, 2, this is 3, 4, and 5. 4 pi over 3 and 5 pi over 3. So this one has 4 answers. Okay? And then last here but not least, what are we going to do? Add 1. So 2 cosine squared of x equals 1, and then divide by 2, so we get cosine squared of x equals 1/2. Square root both sides. Don't forget the plus or minus. Good. So we have cosine of x equals plus or minus. This is the square root of 1 over radical 2. Yeah. We'd have to multiply top and bottom by radical 2. Yeah. So that 1 times radical 2 is just radical 2. So we get radical 2 over 2. Okay. So now this is saying what's cosine coordinate has the number radical 2 over 2. Those are all the 45s. Yeah, good. 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are the odds. 1, 3, 5, 7. All right, can you check all of your answers?
Yeah.
You absolutely can. Okay. All right. That's it. Delta math.
So what's the longer side? So over here, if we go to this one, what's the ordered?
Oh, that was pretty good. That was only 23 minutes.